This video is for FreeCAD absolute beginners. I want to go through all of the tools necessary to make models like this. This was a cylinder head that was made completely in FreeCAD part design, which we'll be covering today. And I anticipate this to be a pretty long video because there's a lot of tools to cover to make something like this. Of course, watching this video, you probably won't make something like this straight off, but you will know all of the tools that would be required to make something like this. And then it's just up to practice to be able to know what tool to use when and how to make the models that you wish to make. But this was made completely in the part design workbench, and we will cover the tools to be able to make this. Now, this Corsair also was made almost completely in the part design workbench, and I think you actually could make it in part design if you wanted to completely. Likewise, this chair and this wheel and this compressor, and each of these also I have videos on my channel where you can make these step by step with me. So I recommend watching this video first to get a good idea of the fundamentals, and then you should be able to go on and see how I use the tools in the part design workbench to make each of these models. So let's get on over. I'm going to close these. We'll get on over to the start page. And this is what FreeCAD looks like. There is a lot to FreeCAD part design, and I anticipate this will be a longer video. It takes a lot of effort to make something like this, but fortunately, I've had help. Thanks to Brilliant.org, I've had the support in making a complete guide here. There are many courses to take on Brilliant.org, and I have especially enjoyed the scientific thinking course. I have covered finite element analysis on this channel, and the structure section of scientific thinking on Brilliant.org offers a similar way to understand finite element analysis mesh and the forces that can propagate through structures also. It helps me learn more effectively than other material because there are animations that make it easy to visualize what is happening and do so much more effectively than just looking at static images on a page. This attention to detail is what emphasizes understanding for spatial and visual learners, like me, and is evident in every level throughout the courses on this site. I especially appreciate this because my first videos covered math, and as I learned how to make content with these videos, I realized what a challenge it is to illustrate things that are clear for understanding. Brilliant does this so well, and they do it with animations that work, which if you are as concrete and mechanical as I am, it would be something that is important for you too. The scientific thinking course can take you through learning about gears, fluid flow, structures, and more. Now, FreeCAD is programmed in C, but most of the user interface, add-ins, workbenches, and macros are programmed in Python. And I'm eager to start the Python course in Brilliant and potentially begin contributing to such an awesome open source platform. Whether you are a student trying to have help doing math homework, a university graduate trying to pick up an employable skill, or just someone trying to stay sharp, I think there's something for everyone on Brilliant. Most of all, I'm so happy to have help from people who have the same goal as me, to make complicated information simple and accessible for everyone. Click on my personalized link in the description below and see what Brilliant can do for you today. The first 200 subscribers will receive 20% off. So now that we're in FreeCAD, straight off, if you ever see something like the report window that pops up down here, I don't use the report window very much, and so if it gets in your way, I just drag it over here, and then it kind of hides in the back, so it doesn't get in the way at all. This will be the first time after you install FreeCAD. This is what FreeCAD looks like. Any file that you've opened recently will show up here, and you have examples that FreeCAD gives you down here. You do have some help options, right? It gives you some links to user hubs. It has documentation on the major workbenches, which we'll go through, and it shows you where to get help from the community, and this is development related here, probably not relevant for an absolute beginner. So let's go to part design example, because that's what part design is. That's what this video is about, right? Part design. So I go into my part design example, and this is an example of a part that has been modeled in FreeCAD. So you could 3D print this if you wish, or you can measure it or analyze it or do whatever you want to do in FreeCAD, which you can do all those things. How do we adjust our views when looking at a part? Well, here I've got a keyboard monitor so you can see all of the hotkeys that I use as well as how I click my mouse. So keep an eye down here if you get confused on how I use my keyboard or mouse. I can pan my view up and down by using the center mouse button. I can roll my view by using the center mouse button and simultaneously right-clicking. So I can roll my view around. I can zoom in and out with my scroll wheel, right? I move my scroll wheel forward and I zoom in. I move my scroll wheel back and I zoom out. So those are the major view controls that you have, but you can also do preset views, like this is the front view, right? This is the top view. This is the side view. This is the rear, bottom, and other side. So you have these preset views up here. You also have isometric, right, which is basically viewing it at an exact angle, kind of on all three planes. All right, so you have some views down here. I never mess with that. So this is an example of how to move your screen. Let's go into the sketching environment now. Not the sketching environment, but rather just new part environment. So right here, I have the option to create a new object. This button does the exact same thing. Create a new, in our case, empty document. All right, now make sure that if this says start, which it probably does, you scroll down here to part design. You can see these are all the different workbenches that FreeCAD has to offer. And if I change to a different workbench, you'll see that my options and tools up here change. So all of these represent a very high selection of different tools you can use for different things. We are only doing part design today, but it is the absolute best for beginners. And it is the absolute best for beginners for a number of reasons. It is very straightforward. If you are an absolute beginner that has never used a CAD platform before and you start using the part design workbench, then you'll be able to transfer your skills and have a good understanding of how to use SolidWorks or Onshape or Creo or Solid Edge or any number of parametric modelers. Libre is a great one as well. And so you'll be able to transfer your skills to other platforms if you've never done modeling before. Likewise, if you have some parametric modeling experience, say in SolidWorks or Libre, the part design workbench has a workflow that works a lot like those, so you'll be able to understand FreeCAD a lot more quickly and effectively than with trying to use any of these other options. So part design is probably the best for absolute beginners and kind of no matter who you are. Now, if you're coming from 2D modeling like AutoCAD, do yourself a favor and forget everything you've learned about the 2D modeling environment. I get a lot of comments from drafters on the channel that are unnecessarily underperforming and unnecessarily frustrated because they're approaching 3D CAD just like it's 2D CAD and it doesn't work because you have to think differently. So forget everything about AutoCAD and focus on this like it's something completely new, because it is. So here we are in FreeCAD. Now I like the dark mode, so let's go from style sheet to no style sheet to pro dark. If you like dark mode, apply that, and I think that looks just beautiful. And you know what, while we're in the settings, let's go to a few other things. Over here, right, you can scroll this way and find your units. Right now I'm in standard millimeters. If you prefer inch, I recommend imperial decimal, but there's a few other US options that you can experiment with as well. But imperial decimal gives you decimal places. That's really well cut out for mechanical engineering, what FreeCAD was meant for. Great. So other things, if we go to display, I just showed you how to navigate your view, of course with zoom, pan, and roll views. If you don't like those controls, you can come over here to display, navigation, and then you can change the controls from here, and this will tell you what the controls are that you've chosen. Let's go to Sketcher now. I like these settings under General. I don't like having Escape being able to leave the sketch edit mode. That's highly arbitrary, but some habits that I developed using other platforms. So if you're in a sketch, which we'll go through, and you hit Escape a few times, you can leave the sketch. And I like having that setting off. Auto remove redundance is something that we'll talk about redundance later. And I like having that on. So we're going to say OK. All right, now we're in part design. The first thing that you generally do is create sketches when you do CAD. So we're going to go through the sketching environment and everything that FreeCAD has to offer. I think it's a great sketching environment. To create a new sketch, we go to this yellow and white button that says Create a New Sketch. Click on that. And then we have 3 planes. Now, do you remember the views where I had my front view, top view, right view, and so on? It is best practice to model the part to where this plane kind of runs along the top of the part. If I look straight onto this plane, I'm looking at the front of the part. If I look straight onto this plane, I'm looking at the side of the part. You don't have to do it that way, but it's best practice. So let's say that I want to sketch out like the top of my part. Let's go onto the XY plane and learn how to sketch, right? I simply click on the XY plane, or I can choose it from this menu, and I click OK. Now, there's a number of sketch tools to go through. I can create, this is the first one here, I can create a point in the sketch. And that's not particularly useful, right? I'm just going to box select it. Of course, I take my mouse, drag it, box select it, and hit the delete key to get rid of my point. The next tool is I have a line tool, much more useful, right? I click somewhere else, and I have a line that I've drawn. Way useful. Now, an arc tool. This is very useful as well. I click a point, and that will be the center of my arc. I click again, and now I can draw my arc around the center point that I just clicked, and I click a third time to complete my arc. Next, I can draw a circle. I choose a point, I choose another point, and that draws a circle in much the same way that I've made an arc. I have this little ellipse thing, right? And it's not too often that you'll need to draw ellipses, but I click to where a imaginary center of my ellipse is, and then I can make the ellipse as eccentric as I wish. So that's how we draw ellipses. I almost never use that tool, but it is extremely handy to have in FreeCAD. Let's go with a spline. This is kind of a tough one for beginners, but with my spline I can click in many points in kind of whatever sequence that I want. And then if I hit the escape key once, it draws a spline that is relative to the points that I've drawn, right? So I can drag these points that I've clicked and it changes the profile of my spline. This is kind of hard to use and kind of hard to define, but it's extremely useful if you need non-constant radius geometry that works pretty organically, you know. But again, a little bit hard for beginners. All right, let's go with polyline. So if you remember my line tool, polyline allows me to get a new line every time I click. Otherwise, it is the exact same thing as this line tool that we just used. Again, I'll highlight everything and delete. Let's go with a rectangle, right? I click 2 points, and those 2 points become the corners of my rectangle. I have a polygon. We default to 6, as that's a pretty common polygon, but I can choose a square, pentagon, hexagon, heptagon, octagon, and so on. All right, next one is a slot. If you need to make a slot shape, this is incredibly useful. I simply click 2 points to define my slot, and as you can tell, this slot is simply made up of 2 arcs and 2 straight lines. So you can draw your own slot with 2 arcs and 2 lines, but this saves a lot of time. Likewise, just by clicking the same button and moving up, I can make a vertical slot instead of a horizontal one. Alright, the rest are sketch tools that we'll get into, but those are the ones that you actually use to draw the elements of the sketch. So maybe I want to make a house shape. That's pretty simple. I can choose my polyline tool or my line tool, right? If I choose my line tool and I go to draw a house shape, then you can tell I just draw it line by line here, or I can choose my polyline right here. And I can hit escape to get out of my sketch tool, right? So there's a few things about this. I can drag anything anywhere, and these points are connected. I can delete elements of what I've just made by highlighting something and hitting the delete key. So what if I draw a line and I want this point to be connected to this point? Well, you can do that initially, because when I hover my mouse over that point, it turns yellow, and I get that little red thing that shows up on the lower right part of my cursor. Those are known as constraints. In other words, if I highlight this point yellow and click to draw my line, it constrains the end of this line to always be connected to the other line. That is called a constraint, or a relation, and there's many of these that you can have in your sketch. Alright, so maybe I'll highlight this line, and what if I want this line to always be vertical? Well, there's a tool for that. That would be known as this little vertical guy. So I can highlight my line and click on this vertical guy, and now no matter what I do, this line will always be held vertical. It is very important to add these kinds of constraints and relations to your sketch. It is best practice to always fully constrain a sketch, meaning I want a sketch so defined that I can't click and drag anything. So you'll notice that I have this little point here. This is called my origin. If you recall, we had a top, front, and right plane, and we're currently sketching on the top plane, or what we would call the XY plane, as FreeCAD would call it. Well, the place where all three planes intersect is known as the origin. There's only one point that all three planes share. And so I can use my origin to my advantage to help position things. Maybe I'll delete my house shape and go line by line. I'll grab one line, or my line tool. I'll highlight my origin yellow, as I've done before. And I will go to draw a horizontal line. You'll notice on the lower right of my cursor, you have that little horizontal line. That looks a lot like the horizontal line in this little toolbar up here. That's telling me that if I click in that position, it will automatically add a horizontal for me, which is what I want. Now, if I check to see how I can move this line, indeed, it only will move horizontally. This little guy right here means coincident. Being coincident means that it is fixed upon this line. In other words, one point is fixed upon something else. That's what coincident means. So, for example, if I draw a point, then I can choose the coincident relation, and I can choose this point to be fixed upon this plane, right? And now it is fixed, coincident. All right, so we have that worked out. What if I want this to be a specific length? Can I give this a dimension? Well, I sure can. Over here, I have, I think my toolbar is a little bit busy, so I'm going to move this up here, and this up here, and this up here. There we go. Now I can see all my red tools. So now I've got a horizontal dimension right here. I'll click this line, and we'll make it 50 millimeters. And you'll notice it turns green. That is the goal of sketching. We want everything to be green like this, because green means that we're fully defined. FreeCAD knows exactly where this line belongs, because we gave it the definitions of where it belongs. We told FreeCAD this line must be horizontal, this point must be coincident upon this plane here, and we told it that must be a length of 50 millimeters. So let's draw our house shape some more. By draw, maybe I should say sketch. We'll come down here. All right, I've drawn my house shape. Now, what other constraints and relations can help us get a green sketch? Presumably, I want this line and I want this line to be the same length. For that, we can choose equal, right? I choose the equal tool, and my lines become the same length when I click both of them, so that no matter what I do to the sketch, they'll remain the same length. Likewise, I probably don't want to have a crooked roof. I mean, that's kind of contemporary and cool, but for a traditional house, I can choose equal for these lines. Equal length. Excellent. Now, maybe I want to give this house a height on its walls. I'll choose a vertical dimension, right, which is a lot like the horizontal dimension, just flip 90 degrees. And I'll make this something like 40 millimeters. Now, you can see that this is green, and this is green, and the only thing that isn't green is our roof. So, let's give the house an overall height. Maybe I can choose my vertical dimension, I can choose my roof and my origin, and give this a height of, say, 60 millimeters. Well, now everything is green, so we were able to fully define our sketch. Now, what if I wish to edit my sketch? Maybe I want to have a perfectly round roof. Well, let's give that a try. I'll select the parts of my roof and hit the delete key. And you'll see I'm still fully defined, I just don't have a roof now. I'll choose an arc. That would be my arc drawing tool here. I'll choose a point kind of in the middle. And I'll choose my endpoints. So I should be, when I move this, I should be coincident to my walls with my endpoints. Now, if they're not, I still have the option to add the coincident constraint. I'll choose coincident. In fact, you know what? If I'm fixing a point on a point, I shouldn't use coincident. I should use this point right here. This is a coincident constraint, but it is for points only. So I'll choose this point, and they're fixed together. And I'll choose this point, and they're fixed together. But that's not good enough. I mean, how do I define this? Well, what if I want my arc to end completely on horizontal so that I don't have a sharp edge, right? You can kind of see where they intersect right now. There's that sharp edge. What if I want a perfectly smooth transition? Well, I can select my arc and my wall, and I'll choose tangent. Bam, right? So we are fully defined. What if I hit Control Z to undo the tangent constraint that I've just done? Another way of doing this is taking the center of my arc and this little endpoint of my arc and setting them to be horizontal with that horizontal tool. Now this point and this point are set to be horizontal, and you have that same smooth transition, because that's just the basic way that geometry works. It's the same thing as putting a tangent there. I can also delete my constraints and relations by selecting them, right? I can click that horizontal I just made and say delete. And now we've deleted that. I can also dimension this with a dimension, right? Arcs are often dimensioned by their centers. So I can select a vertical dimension here. I'll select my arc center. And I can select my origin here. And I can give this a distance of, say, 20 millimeters, right? And that will define the distance of the arc center point. And that fully defines our sketch as well. I'll delete my dimension. Maybe I'll even delete my arc. What other things can we do with FreeCAD? If I go back to a normal roof, let's say I want a 90-degree angle on the elements of my roof, right? So I want a 90-degree angle between these two lines. Several ways to do that. I can choose this perpendicular constraint that I select both lines and they're held perpendicular. That makes sure that these are 90 degrees apart. An interesting anecdote, as I move this, the way that the geometry works is we're actually making a perfect arc. This top point here is tracing out a perfect arc, which is kind of fascinating. But anyway, so we talk about degrees of freedom in our sketches, and we want our degrees of freedom to be 0. And we're down to 1 degree of freedom right now. That means I can only move this point in 1 degree. And so I can simply fully constrain this by making sure that these are equal. And voila, we've done it. But maybe you can see that equal is constraint number 14 here, and perpendicular is constraint 13. And I can track my constraints in this menu right here. And so I can choose to delete constraint 14 from here or from this sketch. Now that we've deleted constraint 14, how else might we be able, and I'll delete constraint 13 as well, how else can we define this? Well, I can choose an angle tool, right? So I select this button, fix the angle of a line or angle between two lines. I click on the two lines, and I can make that 90 degrees. And now it's held to be 90 degrees, and I can use the same equal as before. So you can use perpendicular, or you can use angle and select 90 degrees, and it works out the same way. Likewise, I can choose a 60-degree angle, and that will give me a roof of 60 degrees, or 30, right? Whatever we want. So I'll delete that. Okay, what other tools are worth using? What if I delete my house to begin with, right? You can see, whoops, didn't mean to do that. We'll come back here. So down here you can scroll between the start page and the part that you're working on. So down here, I have my origin off to one side of the house. What if I want my origin to be in the exact center of the house? Well, there's a lot of benefits to that when you start modeling. So what if I delete everything and decide I want my house to be centered? I'll select my rectangle and draw a rectangle. Now this is known as the symmetric constraint. So maybe I'll click my 2 points along the top here, and I want them to be symmetric about this vertical green plane. I'll select that green plane, and then I'll say symmetric. And you'll see FreeCAD has made sure now that whatever I do, these points will be symmetric about this green plane. I can do the same thing, right? Here, here, and here, and choose symmetry. And now I am both vertically and horizontally symmetric. Now, a cool thing is you don't have to choose a line to be symmetric about. I'll delete my rectangle and draw a new one. I can choose symmetric, and I can choose this point and this point diagonally to be symmetric about this center point. And now my rectangle is completely symmetric about my origin. Excellent. Now I can choose my roof, and notice I have a little automatic constraint with my plane that is coincident. So if I click on that, then I know that my line will be kept coincident onto my plane. So it really helps to know your automatic constraints. They always show up on the bottom right of that cursor. And there we are with another house shape. But I have an extra line here. Now if I delete this line, it works out. Kind of. I lose some of my constraints and relations. That's a problem because I want to make sure. I'll hit Control Z to bring that line back. I want to make sure that I adjust things properly and everything stays constrained. So you can argue that I can delete my line and then I can choose my coincident tool and reconnect these lines. And we're kind of back in business, right? And then I have to take this point and make sure that they're horizontal. And now I'm moving like how I was moving before, but that's kind of a lot of work. So sometimes you have a line that is really useful to be there, but you don't want it to actually be part of your sketch. You just want it to be there for reference. And when we want something to be there for reference, we'll choose this button. Toggles the toolbar to or from construction mode. So if I highlight that line and hit that button, it turns blue. And that means, well, this line isn't actually part of the sketch, it's only there for reference, and I can have all of the constraints and relations that I previously had without having to worry about this line anymore. Likewise, maybe I want the elements of this house to fit around a circle. Well, if I hit this button without anything in my sketch selected, then it changes my sketch tools over here to be blue. You can see how I toggle them from white to blue. So maybe I'll draw a blue circle around my origin. And I want to define it to make sure that everything here will fit around a specific radius. Now, maybe I'm actually going to delete my circle and instead make the center coincident with this plane so that my circle can move up and down. Well, maybe if I want everything to kind of fit around a circle, I'll select my circle, select this line, and choose the tangent, which we've used before. And that makes sure that this line intersects with this circle in a manner that they are tangent. And then I can choose my roof right here and my circle, and we'll choose tangent. Right here. Lost the button for a second, right? And then how else do we move? Well, everything is tangent, so then now that I know that my roof and my floor can form a circle, I can dimension it however I want. But if for some reason you have to dimension a house that way, you can use a construction circle to easily make sure that it's dimensioned properly. All right, what other sketch tools are useful? Sometimes I might say, I just want to lock this point down and I don't care about what dimensions it's given just as long as it's locked down. I'll select the point that I wish to lock and I can hit this little lock button and it automatically just gives it the vertical and horizontal dimensions that it needs, right? So it constrains us that point. All right, now I can give these 2 points a vertical dimension here. I can give these 2 points by selecting them a horizontal dimension as we've gone through. But you may say, I just want to dimension the length of this line or just whatever the dimension is between these two without having it vertical or horizontal. Well, here's a nice little diagonal dimension. And that will allow us to diagonally dimension these 2 points or diagonally dimension that line. Likewise, what if I want to give this circle a size? Well, I can choose a radius here. And I can give it a radius of 40 millimeters using this button. Now, what if I care about diameter? Well, I can click this little drop-down arrow and I can choose diameter from there. And now when I click it, I can give it, say, a diameter of 100 millimeters. So if I wish to fully constrain this, it says that I have 2 degrees of freedom. That means my sketch can move in 2 degrees. In this case, I can see that these points can move horizontally and vertically. So if I select this point, and I select my origin, and I choose horizontal, I can give it a horizontal dimension. Now we only have 1 degree of freedom, and that is I can move this vertically. So maybe I'll select my point, select my origin, and give this a vertical, right? Let's say 30. And my house shape is fully defined. Excellent. All right, so I'm going to draw a little bit more of a simple house shape. I'm going to, of course, toggle this back into white. I'll use my polyline tool. And again, I'm making it horizontal. And you can see that little vertical auto constraint. Maybe we'll make this coincident. Great. So to constrain this, I want this to be symmetric. So, I want these two lines to be of equal length, and that would make it symmetric. So I can either choose equal, and that makes these points symmetric, or I can use a symmetric constraint as I've used earlier. Now I can choose a, say, horizontal dimension. And we can go with 100 millimeters. Let's choose a vertical dimension. Let's say 200 millimeters, right? Kind of a tall house shape. And then I'll move my roof up so it looks a little bit more house-like again. Maybe from here to here, we're going to say equal, right? So hopefully these worked examples are starting to make sense on how we constrain our sketches. I'll give this a vertical. Now, if I select a point without selecting anything else and I choose a dimension, it automatically puts that dimension on the origin, a nice little time saver tool. So I've added a 300 millimeter dimension to the height of my house, and I think we're looking pretty good. Maybe a few other tools that I haven't covered yet. I'll go back to drawing a construction line here. And what if I want my roof and this line to have the same angle? Well, we'll make them parallel. This means that they'll be always at the same angle, so that if I change this by double-clicking on the dimension and making it 250, the angle of this line changes to the angle of this line, right? So that's the parallel tool. So we've covered coincident, coincident, vertical, horizontal, parallel, perpendicular, tangent, equal, symmetric. This one is just another way of locking things down. And then we have the lock, which adds dimensions, horizontal, vertical, our diagonal dimension, our radius, and our angle. This is a little bit complicated. I don't think you need to worry about that one as a beginner. All right, maybe one last tool to go through. I'll change this back to driving dimensions, or white. What if my roof, what if I wanted it to have an arc or a radius between these two lines so it doesn't come to a sharp edge? Well, this is a good thing for this tool right here, right? So this is create a fillet between two lines. So I choose 2 points where I want my fillet to meet these lines, and it automatically adds a little fillet. Now you'll see we lost some constraints, relations, dimensions, etc. because we've broken the line segments to make a fillet, or what we would think of as just an arc. So we have to reconstrain some things. And there's no right or wrong way of constraining. There are better ways than others, and that's called design intent. But from here, I'll just make these lines equal. And then I probably need to give this center point a height. So I'll choose my vertical dimension and say 230. And then maybe I'll choose my radius and give my arc a radius. Maybe give that a radius of 20, right? Now we're fully constrained again. So that's called a sketch fillet, or create a fillet between two lines, according to FreeCAD. This is for trimming an edge and extending an edge. That's a little bit more advanced, and I don't think we have to go through that for here. Oh, maybe I'll do the trim, the edge trim. So let's say I've got intersecting lines. I simply choose trimming an edge. From the point of intersection, if I click this side, it gets rid of that line that I trim, right? So it can be useful. It also adds a coincident relation at the point of intersection. Okay. So hopefully that was clear enough. There's my house shape again. I think I've covered everything that is necessary to make sketches with. This is not something that you just go through once and all of a sudden you can sketch, right? This takes practice. It takes a lot of figuring out on how to make a sketch go right. So if I delete my house yet again, and I redraw my house, right? If you don't know what isn't constrained, well, first off, something that is white is a good hint, because if I give this a dimension of, say, 25, and I say, wow, I have white elements and it's telling me that I have 1 degree of freedom, how do I lock that down? Well, clicking and dragging says, oh, you know what? I know that I have to fix this point that's moving around and it's moving in the vertical direction, so I'll give it a vertical dimension, say 50. So clicking and dragging and this little degrees of freedom menu are very helpful. Likewise, I can click on this degrees of freedom and you can see that this point turns green when I click on degrees of freedom. That directly shows me what the degree of freedom is. In the earlier version of FreeCAD, that was a highly requested feature. Alright, so we click the origin, we'll say make that vertical. I said horizontal by accident. I'll hit Control Z. We'll click that dimension and say vertical, and then we have 1 degree of freedom. We can only move up and down here. Maybe I'll lock that in by going vertical for 90. So if you draw a whole bunch of sketch elements and you have trouble constraining them, it might help to draw one sketch element at a time and constrain each one, right? So maybe I'll draw another line. And I know that I want this point and this point to be symmetric across my center, so I choose these 2 points and my center, and I select symmetric, and we're fully constrained again. And then I draw a vertical line. And my auto constraints make me fully constrained again. And if I draw a line from a known point to a known point, a line is simply something that runs between 2 points, so I'll be fully constrained again, right? So those are some tips on how to do the sketch. Now, what if I try to add a diagonal line onto something that's defined? You'll notice Sketch contains redundant constraints. Redundant constraints, and notice that it's automatically removed. Redundant constraints means that there is more than one thing that tells my sketch where to be. Whoops. So even if, right, like it's giving me the right number, 47.17 millimeters would be the length of that roof to solve that, but since I already have dimensions telling it where it needs to be, no CAD platform, FreeCAD, SolidWorks, whatever, likes or will take multiple dimensions or relations that tell the sketch how to define itself. There can only be one set of complete solutions that tell the sketch where to be. So it gets rid of my dimension that it doesn't like. Now that's because I have auto remove redundance checked. If I uncheck Auto Remove Redundance, and I say OK, well, it still auto removes redundance. I think that's just kind of a, yeah, you know what, let's get out of this sketch. We're going to say tasks, close, and edit sketch. And whoops, looks like my toolbar kind of moved around on me, so we'll take these two and drop it back down. Now let's try. Yeah, it's getting rid of it. Okay, sometimes, I'm going to actually recheck that. Sometimes you may come across an error that you can't recover from, right? It doesn't just automatically remove. And so then you have to go through and figure out what about your sketch needs to be removed so that there's only one solution. Now, maybe you want to just measure something, right? Maybe these are the dimensions that you want, and you want to figure out how long this line is. Well, you can do that several ways. First off, you can overconstrain your sketch, but check this reference option. And just like the blue reference line that we had here earlier, we have a blue dimension, which means that this isn't a driving dimension, it's just a reference dimension. And we can measure the roof that way. Likewise, if I delete this, I could turn my sketch geometry blue and white using this button. I can change my dimensioning tools blue and white using this button. And so I can put a blue dimension down here. So those are ways that I can have reference dimensions, just like I've had some reference sketch elements. All right, so this takes practice. Practice fully defining sketches. It's like a little puzzle in a way, and hopefully it's kind of fun. And over time, you'll be able to do this just like you're ringing a bell. You'll be able to look at a sketch and understand what needs to get defined straight off. So don't give up. It gets easier the more you do it. Here we have a fully defined sketch, and this is the next chapter. How do we make a solid out of this sketch, right? How do I make a house shape? Well, let's close, and let's talk about in the part design workbench, which it looks like I've reset my toolbars again. So I'm just going to click and drag these down. How do I make a solid out of this? I'm going to choose this little pad button right here, right? So I have a sketch, and if I choose this pad button, by padding this sketch, you can see that we've generated a solid. Now this is the editing menu where I can change how many millimeters I want to, right? I can click up, I can click down, or I can type a number, and it will give me whatever distance I want. The idea is pad is often called extrude in other platforms, and we're simply taking the profile of the sketch that we've made and pushing it out of the plane of the sketch, right? Just like it's extruding. You can see it looks like something extruding out of the sketch. All right, so I hit the Enter key, or likewise I can hit this green OK key. And there I have a solid. So what if I want to add a chimney? Well, maybe I want to make another sketch. I click in this little blue area first, and I make sure that nothing is highlighted or selected. And I choose a little sketch menu, and that brings up my planes. And so I can make a chimney by selecting my plane again. And maybe I'll make a rectangle, right? And then I want to dimension my chimney, so I can choose a horizontal dimension, and I'll select this line and say maybe 10 millimeters, and I'll choose my point and my origin and do another horizontal, maybe 7 millimeters, right? And then I'll choose a vertical, and I'll select this line and say another 10 millimeters, so it's a square chimney. And then I'll select with my vertical dimension, maybe 20. So it's not quite in the middle, but close. And then we'll close. And then I'll choose pad again. And you can see that as we're coming out, but we're coming out the wrong side, right? We want to come up through the roof. So maybe I'll say 50, and I want to choose reverse. And that will change my direction. Now, looks like 50 actually isn't large enough, so we're going to say 75. Right, and there we're starting to come out of the roof. Hey, that's pretty cool. Looks like a chimney. So I can go ahead and select that and say OK. So now we've got a house with a chimney. And both times we've used this pad tool to be able to do that. However, there are many options besides just pad to be able to make a solid. So let's go through some of those. But first, before we do that, I'm getting ahead of myself. Let's talk about a few other things. I don't have to choose a plane to sketch on. I can also choose a face. So I can choose this face right here and say create a sketch. And now my view changes so that my sketch is on my face. So I can create a little polygon right here. And we should, in best practice, go through and fully constrain this polygon for demonstration purposes. I'll close without doing any constraints and create a little pad just to show you what it looks like when you choose a face that's not on a plane. So now I've got a completely unconstrained pad that is coming out of our roof. I'm going to delete that. And delete the sketch. Right click, delete. All right, so let's talk a little bit about the structure of our tree. This is known as our history tree over here. And as you can see, I've made my first pad, which is the house shape, and then I have another pad, which is the chimney. Now, what if I wish to go back and edit some of the dimensions of my house? I can do that. I've got this little drop-down caret that has my sketch, which is my house-shaped sketch. And if I right-click and edit my sketch, maybe I'll shorten this to 75. If I close that, you can see my solid has a much shorter roof and my chimney stays the same. Well, let's say I have to edit my chimney now. Well, I know that this is the pad that created my chimney. So I can edit my pad, maybe down to 75. That was my original one. All right, 75. So I've lowered my chimney. So if you feel so inclined, it is a great practice to choose this rename right here, and I can say house body, right? And then I can rename this to say chimney. I think that's how you spell chimney. I'm not a very good speller. I'm an engineer. We're not paid to spell. All right. So that's how we do our parametric modeling. We can go back into the tree and change certain parameters, right? Maybe I want to change the location of my chimney, and I can make this, how about 5? And that will move the chimney to one side of my house. So that is how we can do some modeling where we're not just sculpting clay, right? Blender is known as a direct modeler and it's great for animation. But for engineering, we have parameters and we need to change all the parameters. And so this tree gives us access to make the changes that we wish for editing parameters. I'm going to create a new part now. And notice I can always tab over to the part that I've been working on. And if we feel so inclined, we can save. And then I called that house, so it shows up down here as house. And then I can tab over to my unnamed part. Now, don't be confused because house is still in my history tree. The history tree just has all of my open parts that I'm modeling with. So I can still access my house history tree while I'm editing my other part. If that confuses you, then just go ahead and close house, and then you only have one part in your history tree. So in this new part, let's work on another sketch. We'll go on to the, say, XZ plane, and we're going to say OK. I'm going to draw a sketch. Say we'll start off being coincident to this line. And you know what? I'm going to switch over to polyline. And I'm going to draw this sort of sideways U shape. All right, great. Now I want this line to be vertical like this line. So if I desire, I can make it vertical. I can make this line and this line equal. I can make this line and this line equal. I can make this line and this line equal. You can tell I just kind of want to be symmetric about this red plane here. So everything looks like it's acting kind of symmetric. The next thing is, we'll just give it some dimensions. I'll take this line, give it a vertical dimension. Let's say we'll make it 50. We'll take this line, we'll give it a horizontal dimension. Let's say 30 is good. Select vertical dimension and give this line a dimension of, say, 15. Then we'll go horizontal and give this line something like 25. You know, that's a bit thin. 15. And then we say, oh, but we've added all the dimensions. Maybe I'll click and drag and see, the whole thing needs to be constrained relative to the origin. So we'll grab the origin, we'll grab this little point, and now we're fully constrained. I'll give that 60. So we'll close that. In FreeCAD, I can choose to revolve a sketch around an axis. So if I choose this little revolve sketch, right, I have axes that kind of correspond with the planes. The origin is in the middle, and I have my vertical axis right here, which you can also call the x-axis. But as you can tell, FreeCAD predicts pretty well what axis that I would like to revolve around. So Extrude takes the profile of our sketch and just pushes it straight out, normal to the sketch we would call it. Revolve is taking this axis and spinning the sketch around that axis and adding material as it goes. So we've made kind of like a bobbin looking shape. And we don't have to have it be 360 degrees, right? We can take our sketch and make it whatever degree angle that we want. But this is a pretty good visual of how our sketch is revolving around this axis. We can also reverse the direction if we wish. And we can also make it symmetric to the plane if we wish. So the plane that we sketched on, of course, is right here, also known as our ZX plane, and we can just revolve symmetric to that plane around the axis. Of course, I'm going to choose 360, and I hit enter and it's made. Also, you can just say OK. So that is how we make a solid with revolving. Let's skip to another part of part design that I think is a little bit more simple before we start lofting and sweeping. Let's save this. I called that bobbin. Let's create a new part. And if you notice back on the start page, we have bobbin and house in our recent files. So we can go ahead and reopen our file if we wish. I'm going to create a new part. And let's talk a little bit more about planes and reference geometry. Because that's an important conversation to have. So if I create a sketch, right, I have my XZ plane, my YZ plane, and my XY plane, right? And if I cancel this, and I go to create a body, which again we'll talk about in a little while, I have my origin right here that has my x-axis, y-axis, and z-axis, and I have my xy plane, xz plane, yz plane, right? But that doesn't mean that those are the only planes that I can use. So what I can do is say select my xy plane or my top plane, and then I can create a new datum plane with my xy plane selected. And what I've done is I've said I want my plane to be parallel with the xy plane, and then in the z direction I can offset it, right? I can say I want this to be, say, 100 millimeters above my plane, my XY plane. So if I go to create a sketch, right, it shows my planes. This plane is 100 millimeters above this plane. So I'll choose my top plane. In fact, you know what? I'll choose my datum plane that I just made and create a sketch on that. What I'll do first is I'll make a rectangle, and I'll select the two edges, and I'll select my origin, and I'll choose symmetric. I'll choose a horizontal dimension of, say, 15. I'll choose a vertical dimension and make this line something like 10. And it says fully constrained sketch. It's all green. That's what we want. We're going to close that. Now, in FreeCAD, your spacebar can hide certain objects, right? I think datum planes can be kind of annoying to look at, so I select my datum plane, hit the spacebar, and it disappears. If I ever want to see it again, I can go to my tree and find my datum plane, hit the spacebar, and it shows back up again. So I'm going to toggle that off because I don't need that plane anymore. I'm going to choose my XY plane in my tree here and say sketch. I'll choose, say, another rectangle. You know what? Maybe I'll make 4 lines just to make this interesting. And I'm going to draw kind of a strange rhombus. And we'll choose to make these lines parallel. And maybe we'll make these lines parallel also, so that no matter what I do, those lines will stay parallel with each other. This is kind of an odd shape to constrain. Let's say 11. I'll choose another vertical dimension. And we'll dimension this guy down here. Let's say 15. We'll go horizontal. From here to here, let's say 20. Then we can click and drag and see what else that we need to constrain. Maybe I want to constrain an angle between this line and this line. We'll choose that little angle dimension and say 145. So I have 2 degrees of freedom left. And it looks like this line we can constrain to move not up and down anymore. We'll say 15. 1 degree of freedom. Looks like I just need to put a horizontal on that point that I'm dragging. Horizontal, -20. And I'm saying negative because it is on this side of my origin, whereas dimensions on this side are positive. All right, so we'll close that. So we have this tool called a loft, right? I sketched out a rectangle profile here, and I sketched out a kind of rhombus profile over here. And what if I want material to go from this rectangle to this rhombus, and in between slowly turn in from a rectangle into a rhombus? Well, let's give it a try. This is called the Loft tool. And we'll go from here to here. Oh, no. And we'll choose, say, our first sketch. And then we'll have us add a section. And I'll choose my rhombus. And as you can tell, we are changing from our rectangle into our rhombus as we go. Kind of a fun shape. Now the fun part, I can delete my additive loft, and then I can select my two sketches and hit the space bar so they show up again. The cool thing about this is I can choose my XY plane again, and I can say something like in the Z direction 25 millimeters, and you can tell we now have a plane. Maybe we'll go a bit further. And we can say OK to that. What if I choose this plane and I create a sketch on it? Whoops, we'll go back here. Maybe I'll make a circle in between both of these, right? A big circle. And I'll choose my radius and give this a radius of 27. We'll close that. And I'll select my plane and hit the space bar. Now if I choose my lofting tool, oops, I'll cancel that. And look, sometimes choosing the loft will make your planes show back up. I'll select this sketch right here, right? And I'll say that that is my starting sketch. So with this selected, I choose the loft tool. And now it has me add a section, and I'll choose my circle and add another section and choose my rhombus. And you can tell I can use as many profiles as I wish to make whatever shape that I wish. Now I broke one of the rules that is a best practice in order to show you this, so let's go back and fix it. You can see I have 4 corners on each side, but I've got a few more lines than 4 in my view that are running along the body. That's because FreeCAD doesn't know exactly how this corner should interact with that corner and so on. So I can help, as it is a general rule in lofting, if I show my sketches with the spacebar, to use the same number of sketch elements. Here I have 4 lines. Here I have 4 lines up here. But here I have 1 circle. And so going from 4 lines into 1 circle into 4 lines can be confusing computationally to almost any CAD platform. So how do we deal with it? Well, I can edit my sketch. I'm going to choose Edit Sketch, and I'm going to edit my circle sketch. And let's say that I want this circle for reference like we've talked about. So now this is blue. I changed it blue with this button. And we no longer have a circle that is driving. So instead of 4 lines to 1 circle to 4 lines, let's go 4 lines to 4 arcs to 4 lines. And that way we have the same number of sketch elements. So I'm going to choose my arc tool right here. And we're going to go 1, 2, 3, 4. And then it's just simply up to defining where we want these endpoints to be. I'll select these 2 points and make sure that they are horizontal. I'll select these points, make sure they're vertical, and these points horizontal. So now we have 1 degree of freedom. And there's a number of ways that we can solve this, right? We can make a dimension horizontally. We can make a dimension vertically. What if I want this to be a perfect square? Well, perhaps one creative way of being able to do that is to add, let's add a construction line where I select this point to this point, and then another line from this point to this point. And there we have it. Now all I have to do is set these to be equal, and I have a perfect fully defined sketch where this is a square where these points end up. So let's close that, and you can immediately see that as compared to last time, we have only 4 lines because we only have 4 vertexes on our start and end constraints. So it's a much better loft to be able to loft to the same number of elements. Hopefully you see the difference that made. So that's called lofting. Now let's cover another concept known as sweeping. I'll save this. And let's create another file. I'll close my loft down here. So let's create a sketch. Let's do so on our XZ plane. And I'll make sure that my tools here are white. And how about I grab polyline and I make a U kind of shape. We've already made one U shape, so to bolster our experience, maybe I'll constrain this in a different way. I'll select this point, and this middle line, and I'll select symmetric. Now these points are symmetric. I want to do the same over here. This point, and this vertical line, symmetric. And then I can assign a vertical dimension here. Let's say 25. I'll choose equal and make sure the other side is equal. Let's choose a horizontal dimension and we'll give this one something like 35. You can tell I have green elements of my sketch now. If I click and drag, I can see my degrees of freedom. It looks like I need one more dimension there horizontally. We'll say something like 20. And then I need to go up and down, right? So we'll choose this line, vertical dimension, 15. Oh, looks like I've got one more degree of freedom. Looks like this point looks like this line and this line right here, I can just say equal, right? Now we're fully defined. I also could say this point to be vertical to this point, right? Many, many ways to constrain a sketch. Either way, we have this fully constrained U shape now. We'll close that. We'll grab a sketch on the XY plane and say OK. I'm going to draw from my origin a vertical line, and we'll give that a vertical dimension of something like 85 millimeters. I'm going to draw an arc. I'm going to put my center point way out here. And you'll see a little problem that I had. My arc of my endpoint is coincident onto this plane, but I want it to be connected to this point. So I'll use this coincident constraint for points. And I want this to be tangent, so I can select my line, select my arc, and choose tangent. This is telling me that I did have a coincident constraint, but the tangency constraint was applied, and that covers coincident as well, so it removed the coincident that I no longer need, and that's fine. Let's give this a radius of something like 200. I'll give this a vertical dimension, say from its endpoints, say 190. Maybe I'll make another arc whose center is over here. I'll have this endpoint end up being, say, vertical. So we've added a vertical constraint, and let's make sure that this is tangent. There's tangent. All right, so it says we have 1 degree of freedom, and that's got to be our radius. Let's add a little radius here. Let's say 440. All right. We'll close this. So I have this kind of question mark looking hook sketch. That's just some lines, or I should say linear in the sense that it's not closed, right? This U shape is a closed sketch. This is an open sketch because it has not a closed profile. Let's go with sweep. So with sweep, I select this button and it says, what sketch do I want to sweep? I'm going to choose this sketch. And what I'm going to do is I'm going to take this sketch and run it down this kind of hook line and add material as I go around this sort of hook shape. So I'm going to say OK. And then it says, what path do I want to sweep along? I select Object, and I choose my other sketch. And now if I say OK, you can see that my profile has gone down the sketch that I've just sketched out. Pretty handy. Now, Sweep and Loft have a little bit of a similar functionality in that we can change the profile as we sweep down the path. Let me give you an example. I'm going to delete my additive pipe, and I'll use my space bar to show both of these sketches. And let's put a plane right on the end here. Now this may coincide with a plane that we have in the sketch, but I want to show you, or in this part environment rather, but I want to show you how to make a plane when it doesn't. I'm going to select this point and select my arc here, and you can see that when I select my point it deselects and so on. So I'm going to hold Control and select this line and its endpoint. I'm going to choose a plane. And I'm going to select normal to edge, and that creates a plane that ends normal to my arc. So I know that when I sketch on this, it's coming straight out of this profile. I'm going to say OK, and I'm going to begin sketching. Now you'll notice my origin is right where my edge ends. Also, I haven't talked about the view cube, but if I want to go snap straight to my right view, I can just click on the view cube and it goes straight to my right view, and I can select the edges of the cube to give me different views. So let's make something that's still a U shape, but just has different dimensions. The number of sketch elements, like in lofting, applies here. For best results, and sometimes the only way to get results, is to use the same number of sketch elements that we originally started with. So we're going to say, you know what, let's go to my model, and I'm going to hide my datum plane, and then go back to tasks up here. Much easier to look at. So let's go up here and say equal. And from here to here, both of these lines are now equal. From here to here, right, equal, equal. As you can tell, the symmetric constraint that I used probably isn't the fastest, because I mean, look how fast this is coming together. Now what I'm about to add here should be a redundant constraint. No, it isn't. Okay. So we have 3 degrees of freedom. Let's add a vertical dimension here. We're going to say, how about 50? And that kind of oriented the sketch in a way that I didn't anticipate, so let's hit the Control Z button to get our original sketch back. All right, so this is part of the troubleshooting when it comes to sketches. That's why it's sort of misbehaved. You can tell that there appears to be a constraint or a relation that we didn't intend to have. I don't want these to move up as I move this down, and vice versa. So let's go through here, and I'm going to highlight 25, that looks fine. 26 looks fine. 23, good. Let's look at 24. That's this line and this line being equal, right? I'm going to hit delete and get rid of that. And that looks like it solved it. So sometimes you might find a constraint relation that you have trouble with. Just troubleshoot by looking over here and seeing exactly what needs to change for it to make sense. Let's try that again. Select this line, vertical, 50, and that moved in a much more predictable way. Let me try re-adding that now that I have the dimension. And yeah, that's moving kind of peculiarly. So I'm going to get rid of it. Control Z, right? And I'll just dimension everything else and see where that puts us. Next, we're going to say horizontal, 40. Horizontal again, 25. Let's go with vertical, and I'll click this line at 20. That's fine. Oh, and it looks like we're fully constrained. So those equals were probably going to over-constrain our sketch, and that's why it was acting so funny. Let's go with close. Now we want to take this profile, run it down this path, and as it runs down this path, we want it to gradually change into this profile up here. So we're going to choose sweep. We'll choose our first sketch. We're going to say path to sweep along over here. We can see it sweeping very nicely, but that's not good enough. We're going to change it into this shape with different dimensions. So for transform mode, we're going to change it into multi-section, and we're going to add our end sketch. And there you have it. You can see how it slowly becomes bigger until it changes into this new shape. Pretty cool, right? So far we've done extrude, where we come straight out of the sketch, revolve, where we spin around an axis, loft, where we go from one sketch to another, sweep, where we do this. Now we have this tool, sweep a selected sketch along a helix. Very useful tool indeed. So let's save this. And we'll close that. We'll create a new, create a sketch. I'm going to go on the YZ plane. Let's create a circle. We'll create a radius. We're going to say, how about 10, right? That's a good number. We have a radius of 10. Close that. And we'll choose pad, also known as extrude in some platforms. We're going to give this a dimension of, say, 100. So I've made a cylinder. Let's create another sketch now. And I want to choose my XZ plane. Alright, so in this sketch, let's try to make a bolt like something that has threads. I'm not going to make this an official bolt, although you can, right? I'm just going to make up some dimensions. Bolt threads look like this. They usually have a 60-degree angle, right? Maybe a little fillet in there. But I want my bolt to snap to this edge. But if you notice, I grab coincident and it'll snap to my plane here, but I can't select this upper edge. And so I have to rely on a tool to reference the geometry that I've already made that's solid. Right? This is known as import. So I come over here, create an edge link to an external geometry, where I just say import geometry. I click on this, and then I can click on my edge, and now look, my edge becomes selectable, and it gives me that little dot where my edge ends. So I hit the escape key to exit my tool. I'll grab my little point-to-point coincident tool, and I'll just snap onto that. Perfect. So let's make some threads. I'm going to choose an angle, and I'm going to be pretty easy about this and just make these 60 degrees apart. That I have to check my thread dimension chart. That could or could not be correct. We're going to say equal between these two lines, and then we'll say horizontal. Give this a horizontal dimension of, say, 10, right? This is a big thread, very big thread. Great. So let's close this. Now, as I mentioned before, FreeCAD has axes. You can see the axes down here, right? Our z-axis, our y-axis, and our x-axis. And this little orientation tool, right, because it moves when I move, is a nice little shorthand way of looking at the axes in FreeCAD. So I'll grab my sketch, and I'll grab my helical tool right here. And I'm going to say I want this to be a helix along my x-axis. But this is not an expected result. This is not very good. So sometimes in FreeCAD, you need to intersect your bodies a little bit to get what we're expecting. I'm expecting something that looks like a bolt thread. So let me go and edit my sketch, and let me turn this into reference geometry. And I'm going to take my line tool and extend it down just a little bit. Now notice I can't see what I've sketched in here. So now we're kind of sketching inside of this body, and that's a little bit awkward. So we need to have another tool. And that tool is located around here. That's better. This button right here. Switch between section and full view. So I click this button and it sections out my part, so now that I can see everything that I'm sketching. We'll have this guy come down here, and this guy come into here, right? I'll give this a vertical dimension, and it doesn't really matter what this dimension is because this will be inside of my body that already exists, and so they'll merge together. I'll just say that this is 2 millimeters rather. We'll close that, and that is the predictable result that we wanted. So this is something that occurs in all CAD platforms that I know of. This is called zero thickness. When you have a result like this, right, I hit Control Z to go back to where we were. We're saying that we have a sketch that we're moving on, and we don't know if we need to add material or not right where these things intersect, right? Right at that point, is there material or not? So by adding a little bit of extra material inside of this part, we have resolved that error. Now, if you're confused by zero thickness, I have another video on my channel that explains zero thickness in a lot more detail. Feel free to look that up. So zero thickness, Joko Engineering should come right up. I'm going to hit redo. And there we go, right? There's our bolt thread. So if I double click in additive helix, I can change my pitch, and I can change which axis I'm using, of course, and I can change the height, right? I can make the height of my helix taller, but maybe it's awkward to try to define it by the pitch and the height of your helix that you want. Well, in that case, you can change the mode to say pitch and the number of turns on that pitch, and that will fully define your helix, right? So we can add turns as we please. But maybe that's awkward, so you can also define it by the height and the number of turns. I can say I want the height of my helix to be exactly 80 millimeters, and I want it to have 10 turns. That might be a lot of turns. Yeah, that's when it turns black like that, you know you've created something that's really not computationally able to be made. So let's try 7. Yeah, 7 turns. And then we can make this a left-handed thread if we wish. Or we can reverse it, although that's kind of silly to have a hollow helix, you know. But you can reverse it if it goes the wrong way. And we're going to say, okay, so that's how we can make helixes. All right. So if you care to make threads or anything else that's helical, that is a shorthand, easy tool to make. This is kind of a newer feature to FreeCAD, and I could still make helical stuff in FreeCAD before this. It just wasn't as easy. The developers have done a superb job in making this easy. All right, next, we can make primitives. So let me save this. So we can make primitives. I'm going to save this as helix. We'll just close that down and create a new one. So when I insert primitives, I'm simply adding simple shapes, right? And I can say instead of 10 by 10 by 10, maybe 50 by 10 by 10, right? And then I can add in another primitive circle or a cylinder. You know what? That's great. Let's do cylinder. And radius of 10 is fine. Height, maybe we'll make that 50, right? And it just lets us insert some already pre-made shapes if we so desire. I'd rather sketch all my stuff personally. That's a workflow that makes more sense to me. But this is another legitimate way to model. In fact, old school modeling was known as CSG modeling. And it's a way that you can do it. It's totally great and your dreams will come true and stuff. But sketching really is my personal preference. But you can add in boxes and stuff if you just need to model a box and you think that that's an easy way to do it. We'll go through some of the more CSG modeling type stuff in this video later on. Okay, so now let me sketch on my, say, XY plane, and I'm going to draw out a rectangle and select corner to corner to the origin. We're going to say S for symmetric. That's a hotkey, right? Saying S for symmetric is the equivalent of clicking on this button, which, as you can tell, has a little S in parentheses in that description. So almost all these are hotkeys, and honestly, I just use the hotkeys more than anything, but I'm trying to use these buttons to make it simple. All right, so we hit S for symmetric. We're going to go with a horizontal dimension, let's say 150 millimeters. Let's go with a vertical dimension that will fully constrain us at 50 millimeters, right? Let's close that. We'll go to extrude. We're going to say 50, right? So we've just made a primitive. Now, let's sketch on this face. And let's say that I want to put a hole in this face. In fact, let's put a hole dead center on the origin. We'll grab a radius, and we're going to say 15 millimeters, and we're fully defined. We'll close that, but now I'm going to use the next tool. You'll see that this is blue and red. This is creating a pocket, and as I click this, it works the exact same way as extrude, except it removes material instead of adds material. So I can say through all, and there we are. I've got my complete hole through all, totally done. It's brilliant. So as you can tell, I can go into my tree, I can edit my sketch, and I can even say delete my circle, and I can add a nice, how about a heptagon, right? I can do the same thing with my heptagon. And to fully constrain this, I simply grab a horizontal and make one of the lines horizontal, and then I can add, how about a vertical dimension? And I can define that however I wish. Let's go with 19 millimeters. Close that, and it updates parametrically to now have cut a heptagon, right? So This yellow adds material, and it extrudes, or what the part design workbench calls pads, and this one subtracts material, but it does the exact same thing. So what's this one then? Well, this is create a hole with the selected sketch. So let's do an example, right? Because I have to have a sketch. Create a sketch here. Maybe I'll make a circle there. We want to fully define this, of course, because that's best practice. So we'll create a horizontal dimension. And we'll go with 55. We'll make a radius of 6, and we're fully defined, right? One example of something that can go wrong is if you don't have the coincident auto constraint. Maybe you'll say, hey, how come I'm not fully defined? And then when you click and drag, you realize, oh, okay, I need to add either a coincident or a horizontal. So I'll grab my center, grab my line here, and I'm coincident, right? So that's one just example of something that came to mind. All right. So I've selected my sketch, right? It's green, it's selected in the tree. I create a hole with the selected sketch, and I can add, say, isometric hole, and then I can even select this box for it to be threaded, right-handed threads, M1, maybe we'll make that M8, make it a little bit bigger. We'll go with countersink, right? Or whatever you want. You can just choose all the different parameters of your hole, right? There we go. I was thinking that there was some missing stuff there. So we have this, and we can select, certain particular clearances or diameters or whatever we need, but you're the engineer, you're making the hole, you know what hole you need. So get this stuff to be the hole that you want, and then say OK. And then I'll move this back. So this is what, in SolidWorks, you'd call this the hole wizard. It's an easy way to make holes from circles that would ordinarily have a lot of steps to them. Now you can say, hey, we made this an M8 hole, and look, there's no threads. And you'd be right, there's no threads. This is how SolidWorks and other platforms do it too. Threads are very heavy. They're very graphically heavy. They're very heavy on file size. And so threads are not really shown by default. This is a hole that would probably be the right size to tap an M8 hole. Because that's, in a lot of manufacturing processes, what you need for an M8 hole, right? It also makes it easier to inspect for quality before you make the threads. You don't have to use a gauge or something like that. Okay, so we have holes. Now if you need threads, if you need to print threads, that's a different conversation. Apart from the helical tool, there is the fasteners workbench, which I don't think I have installed right now. So we'll get to that at some point, or you can just watch my video on FreeCAD fasteners if I forget to in this video. Moving right along, we have Revolve. Whoops, I clicked the button. Revolve, but this is a groove, right? Because it's a subtractive revolve. So here we have Revolve adding material. Here we have the same thing, but it's removing material. So I guess this is kind of a weird looking part. I'll just carry on. Create a sketch. I'm going to say OK. Maybe I'll create a grooved rectangle. Again, you can't see what I just sketched because we have to section the part here. And so if I create a grooved sketch, I guess I'll fully define this because that is best practice. We're going to say 25 to the origin. We're going to give this length a horizontal dimension of, say, 28. We'll give this a vertical dimension as a line of, say, 10. We'll give this corner another vertical dimension of, say, 25. We'll close that. So we have our sketch selected. We're going to choose groove. You can see we've made a circular groove with that sketch where these inner walls and outer walls both are circular. So that's an example on how to use the groove tool. Same thing as Revolve, you're just taking material away instead of adding it. We have subtractive loft. Same thing. You sketch through a solid, you use your subtractive loft, and then there's no more solid wherever you loft, right? Same thing with subtractive sweep, subtractive helix, and a subtractive primitive, right? The idea with the subtractive primitive is... let me cancel that and make it easier to see. Let's go with a sphere, right? We have a sphere, and let's make it something like 50 millimeters. And then a sphere with a radius of 50 millimeters has been subtracted from my part. It's just a primitive that takes away instead of adds material. All right, so we have done that. I hope that this whole subtractive concept makes sense, because we'd be in for a much longer video if I had to show how to subtract a loft and a sweep. Okay, well maybe a subtractive loft won't take that long, just in case someone is very angry at me. So I can go to my tree, right, and delete my groove, delete the sketch for my groove, delete my hole, delete the sketch for my hole, delete all this stuff, right? This should be pretty straightforward. So we're going to go here. We'll create a sketch on this face. And I'm going to break a rule, because making a bunch of arcs isn't very time efficient for presenting, right? So I'm just going to go from here, and I drew a heptagon. I'm going to draw a circle over here. Maybe we'll make it smaller. We'll close. All right, and one thing that I should point out is, notice that I have this yellow icon by my sketches, whereas this does not have that little yellow thing. This means that the sketches are not fully defined. So you can tell even the platform itself cares in telling you that these sketches are not fully defined. It's telling you that I'm doing something that's not best practice. So I think that's pretty cool. Let's go with, again, our subtractive loft. We're going to go from sketch 1. We're going to add a section and select sketch. Oh, I said pad. I want to remove that. We're going to add a section and actually click on my sketch and say OK, right? So our subtractive loft has gone from this little polygon into a circle and a smooth transition all the way through the part. So that's how you can use subtractive lofts. And you know what the similarities between sweep and loft, if you've watched this video, you should kind of get an idea of how to use a sweep path through there, right? Not too bad. All right. So I don't know, let's just save that. Subtractive loft, I guess. So we're going to open up a new part, and let's make something new. Again, let's go with XZ plane. Create a sketch, create a symmetry by grabbing both corners and the origin. We'll go with a horizontal. Let's go with 100. Vertical. Let's go with, say, 50. We'll close that. We'll do a pad. And this time we're going to, well, let me show you. We're going to go 100 millimeters, right? But what if we want, and if we reverse it, right, then our plane that we've sketched on is right here, and we're going the other way, so we can reverse the direction on the plane that we've sketched on. But if we want it to be in the middle, we can just choose symmetric to plane, and then it goes right in the middle, and it goes 50 one side and 50 the other side. And we're going to say OK, right? So a few things to do. Let's choose this face and sketch on this face, just like we sketched on the house. And maybe I want to add a little detail up here. Well, for that, I'll have to import this little corner point here, or I can import the whole line, whatever, either one works. And I'm going to sketch out a little rectangle. And let's choose a horizontal dimension to be, say, 30 millimeters. We'll choose a vertical dimension, right? We just want to fully define this to be 15 millimeters. Now we'll close. We'll pad. If I choose symmetric to plane, it shows up, right? So if it disappears, then FreeCAD might have some trouble thinking about it to begin with. Just play with some settings and it will come back. We'll go with reverse. We're going to say OK. Multiple solids. So if you run into this error, that means that FreeCAD thinks that this is not connected to this. So we'll cancel that. I'm not sure why that happens because I almost never run into that error, but of course it runs into it in my beginner video. But let's work on fixing it, right? Because if it comes up for me, it'll come up for you. We'll select this line. We'll choose for construction. And just like before, with that zero thickness error, which hopefully you're going to watch my video on zero thicknesses as well. I think that's done in SolidWorks, but it is actually the same thing between SolidWorks and FreeCAD. Oh, and it looks like I missed a few automatic constraints, so we'll add them in myself. This point coincident to this point. And this is a good example, again, of handling an error in a sketch when we're overdefined. So I wanted this point to be fixed onto this point, coincident, and it's telling me that I have too many things that are defining a certain point. It says that I have a redundant constraint that is 16, right? So I'm going to go to 16 and say delete. And now it's fixed the sketch. So those directions where it tells you where the redundant constraint is are pretty good. Let's go to vertical. So that's an example of how to fix, a sketch that has that kind of error. We'll choose a vertical dimension now. It doesn't matter how far we go into the solid, but just because I'm overlapping the sketch into the solid, it'll tell FreeCAD that they're going to be one solid and not two. They'll be connected. So we'll close that. We'll go to a pad, and we'll reverse. We're going to say OK. And now they're connected. I have a little bit of a graphical artifact because my sketch went down in, but this doesn't really make any difference to anything, really. It's just graphics. Okay. So let's talk about some ways that we can pad that are a little bit more than what we've been doing. Let's select this face. We're going to say sketch. Right, I'll create a sketch. Maybe I need to import some geometry. Let's do this coincident from point to point, fixed. We're going to go with horizontal. We're going to say 10. Let's go with a vertical dimension now, say 5. Good. So what if I want to pad this sketch all the way up to this yellow face? That is perfectly doable. What we do is we select pad. Actually, let's cancel that. Make sure that I have sketch 002 selected. We select pad, and we're going to say up to face, and we choose this face. And what the advantage is, if I were just to measure the distance from this face to this face, and then pad at that distance, well, what if I change the dimensions of my cube? Then the pad will only go that same distance and not update. But now I can change the dimensions of my cube, and this pad will go to this face no matter what the dimension is. So it's very handy to be able to use that kind of thing for what we call design intent. Likewise, I can say to last. And of course, it tries to find the last face. In this example, it's not. If I say to first, then hopefully it will be to the first face that we extrude to. And I had trouble finding the first face. So I kind of just prefer saying up to face because, you know, manually specifying the face that I'm going to is excellent. All right, so what if we want to go to 2 dimensions? We're going to edit our pad, and I'm going to choose 2 dimensions down here. And of course, I lose my ability to go up to a face. But again, my first length now is going off one side of the sketch. So I'm going 16 millimeters over the edge. And then this is going 100 millimeters in this direction. So you can also pad in 2 directions. Excellent. I'm going to get rid of this pad now and this sketch, and get rid of this pad and this sketch. Let's move on to something else. Let's sketch on this top face here. I'm going to sketch a circle. We'll give it a radius, that radius tool, and we'll make it 30 millimeters. We'll close that, and we'll do a little pad, and OK. So how do we do some direct editing of things? Fillets are very, very important to many designs. I'm going to take a fillet. Of course, I have to select an edge first, right? So if you don't know what a fillet is taking a sharp edge and rounding it out. It's a rounded end. So I've selected this edge. I select fillet right here, make a fillet on an edge, face or body. And you can see I've rounded that edge out now. Isn't that nice? And I can change the radius of which I round it. So now I'm at 5 millimeters, right? That's probably good. Now I can do multiple edges as well. I can select add, and I'll click on another edge. And when I say OK, I've rounded this face and this face. And then maybe I can do a fillet of a different radius. And I'll do a fillet here, and you can see that it continues all the way down all of the tangent edges. And maybe I can make that 2 millimeters, right? So I can start rounding edges. Now I can also use what they call a chamfer, or some people call it chamfer. I had a professor that always called it a chamfer, which is kind of an unusual thing to call it, but that's what I've been calling it ever since. So a chamfer is just a straight line. You can tell that that's my straight line that was once a sharp edge. And I can change the length of that, right? That's 5 millimeters. Equal distance, you can also say 2 distances. And you can think of that as, an angle to do it. So you can change the angle by which you create this chamfer. So if I make them both 8, then that's, a chamfer at 45 degrees. All right. Let me get rid of my chamfer and my fillet and my other fillet. What if I want this part to be hollow, right? What if it sits this way and I just want a quick, easy way to make this whole thing hollow? I can sketch out a pocket and do a, pocket cut, but that might take a while and I'd have to hollow this part out too in multiple steps. So here we have something called the thick solid command. When I highlight this face, which I say I want this face to be the open face to the hollowness, and I choose thick solid, you can see I've made a box that has a consistent thickness of 1 millimeter all throughout. So it is a quick and easy way to hollow something out. Okay, excellent. Let's try draft. Now, when you work in injection molding or even casting, it's very important to have some faces be angled slightly. So if I choose draft, then let's reverse our pull direction here. And I draft this at, say, 10 degrees, which is a very extreme draft. Then you can see how this is now leaning inwards. I have a whole video on drafting, so you can look up Joko FreeCAD draft. I bet it'll come right up, and you can see how I've drafted these faces. Let's try it again, right? We'll draft here, and if I make this 10 so you can really see, right, we're drafting it kind of, what if we want the draft to be in the same way as this? Well, I can select my neutral plane and I'll choose this bottom face, and now everything is drafted toward that bottom face, but it's going in the wrong direction, so we'll reverse the pull direction and see that all of our faces are now drafted 10 degrees the way that we want. So that's draft. Likewise, I can select this face and I can choose to fillet every edge connected to this face, and it does so, right? A very useful feature. I've just added fillets off of every edge on that face. Maybe I can add this face. And I say OK, and there's all my fillets. So you can use draft and fillets and chamfers all together. These are ways to be able to directly edit the part. Okay. Maybe I'll save that. So that's saved. We're good there. I'm going to make another part. Let's go on the XY plane and say OK. Another rectangle. This time point, point, center. There you go. So we're symmetric again. You've probably seen that 5 times now. We'll go horizontal. We're going to say about 150 millimeters. We'll go vertical. Vertical dimension of 50. We're going to close that. We're going to go to our pad. We're going to say 25. Let's do another hole with our pocket function, right? So I create a sketch, and maybe right here we create a hole. We'll go vertical, and we're going to say 15. Horizontal dimension. We'll say 60. Radius for fully defined, we'll say 5. We'll close that, and pocket, I'm going to do through all. Now, just as before, I can say up to face, choose my face by clicking on this face button, and it will go up to that face. So you have the same techniques with that other pad that we just did. With our view cube, we'll click on this little corner, and that gives us kind of a nice little isometric angle to look at. Next, let's talk about some of the repeating features that we can do. So again, I mean, our planes aren't visible, but if I go to create a new sketch, you can see my YZ plane running through the middle this way, and my XZ running through the middle this way. We can use those to our advantage. Let's go with mirror right here, right? So if we want to mirror a hole, there's our pocket hole that we just created. And it shows us our planes now. It says, hey, how about I mirror across the vertical sketch axis, which is really just a way of saying the YZ plane. So I can specify the YZ plane if I wish. And so now this hole is mirrored across this plane. Okay. Likewise, I can go back and say edit mirrored, and I can change this to mirror across the XY plane. No, the ZX plane. XZ plane, yeah, there we go. And we're mirrored across this. That is very useful. Let's look at this in another way, right? I'm going to delete my mirror. I'm going to select my pocket. Or in fact, I'll click blue and just select nothing. And I'm going to say create a linear pattern feature. I'll choose my pocket, which is my hole. And now I want to have two occurrences over the length of 100 millimeters. Let's change this to, say, 125 millimeters. And now I have two holes over the course of 125 millimeters. Well, I can up this to 3. And now I have 3 holes, and 4 holes, and 5 holes, and 6 holes, and 7 holes, right? So you can specify the length that you want to have your pattern, and then the number of holes equally spaced in between that length. Isn't that fantastic? So I'm going to say OK, and now I have patterned holes. Now let's delete this. And let's say I want to mirror this hole across this plane and then mirror this across this. Now a common error, right, this is not the right way to do it, is to take my hole, mirror it across this plane, and then say, okay, I'm done. And then I want to mirror my mirror, and I want to say take my pocket and my mirror. I can select both by holding Control, and it says only additive and subtractive features can be transformed. And I say, okay, well darn. So maybe I'll take my pocket and choose a mirror feature, and I'll mirror across this reference. And that works, but then how do I get this third hole that's mirrored? That's kind of a drag, right? So that's how not to do it. If you want to do 2 mirrors like this, I'll select my pocket and I come over here to create a MultiTransform feature. And a MultiTransform feature lets me use all the transforms. So I can say right click, I want to add a mirror transformation, and it already goes across my YZ plane. And then I want to add another mirror transformation. And this mirror transformation goes across my other plane, my XZ plane. And now I've added that, right? So I can say, okay, great, we're done. I can do the same thing with, I'll delete that. I can do the same thing with linear patterns, right? So I choose my MultiTransform feature, I choose my hole, and then I right click and I say add a linear pattern. And I choose my number of occurrences. There's 7. And then I can choose another linear pattern, and that's putting a linear pattern on my linear pattern, except this time I want to choose my other direction. How about my vertical axis with the reverse direction? And 100 millimeters is too far, so I have to say like 10. There we go. Maybe I'll make that more like 20. You know what? I'm going to push it. I'm going to try 30. Yeah. And then I can, add another occurrence in there, and I can make an array of holes really easily. So one thing I forgot to mention, let me delete my MultiTransform, is the polar pattern, which works just like everything else. Let me edit my sketch here and just bring this in closer. We're going to take this 60 and let's make it like 6 or something. And we'll make this, 15 is good. Okay. So as you know, FreeCAD has vertical and horizontal axes running through this part as well. We just say polar pattern, which is this button up here. Create a polar pattern feature. We're going to choose our pocket. And it already knows our normal sketch axis, right? That's our axis that is normal to whatever we've sketched. And then I can add occurrences. You can tell I've created a circular pattern. So that's great to be able to pattern around an axis that is already existing. Let's say I want to make my own axis. I can create a plane, right? I select this face, I create my own plane. You don't have to create a plane, mind you, right? I'm just, in my particular case, it works well to create a plane. And I want to go in the Z direction. I'll flip sides here. right? Maybe I just want to position my axis in some weird plane like this. I can select my datum plane, create a sketch, and I'll create a line. And your axis does have to be vertical, right? Or, normal to whatever feature you're trying to pattern here. Now let's go Shift H, -15. So Shift plus H is how you insert a horizontal dimension into your sketch. Just a shorthand way of clicking this button. Let's close that. And now with this axis, we're going to say polar pattern, pocket. And now I want to, right now it's going around this axis, of course, but I have sketched out a different axis. So why don't I say something like 10 occurrences? How does that look? Okay, polar pattern, let me actually edit that. There we go. 10 occurrences was too much. But you can see we're going right around that axis. And we want to go around this white axis that I sketched out. So I say axis, select a reference. I choose my axis here. And I've got a problem, right? My axis doesn't fit. So let's go edit this axis here. You know what? Let's edit the pad. So here's my sketch. I'm going to, of course, I've got my pad. I do my caret off of my pad, and I edit the sketch that produced this pad. And I'm going to give this, say, 500, right? Make it really big. So we'll close that. And then look, my sketch is way over here now because why? Because I defined my sketch and my plane based off of a face that moved. And so when the face moved, my plane moved, right? And so I can compensate for that by going to my datum plane and saying instead of 18, I have to move this like 450. Oh, and then it went the other distance, of course. And let me just show my plane with the space bar. Great. So I show my plane with the space bar, edit my datum, and we're going to say 200. And then this little button right here means regenerate. So this line is drawn on this plane, but this plane moved. And so I have to update some of the changes that I made. So when I click update, my line moves back onto my plane, right? And that should be closer. I'm going to edit my plane one more time. 225, update, that should be good. All right, so let's actually delete this polar pattern. And let's create, so I've got my sketch 002, which is this line, right? We go to add a polar pattern, and we say pocket. And then I say, oh, you know what? I can use that line as a reference for an axis. And I go to do that line, and I have error. Vector has 0 norm. If that happens to you, sometimes you can get away with using a sketch, but it is best practice to select the line that you sketched out to use as an axis and select this new datum line, right? Create a new datum line, and it puts a datum line where that line is, and then the datum line makes an excellent reference. So we're going to say, let's stand on pocket, create a polar pattern, but instead of our normal sketch axis, we're going to select reference, choose the datum line we just made, and now if I add occurrences, you can see we're revolving the pattern around the datum line. So that's a method on how you can use a sketch as an axis around this polar pattern. So let's cancel that, right? And let's kind of show the power of this. I want to make this absolutely gigantic. We're going to go to our sketch, edit our sketch. Let's say 1,000 by 1,000. Close that. And of course, my datum plane moved again. So now we're going to say 500. We'll update that, right? That puts our axis pretty close. So, to show the power of this, let's go with create a multi-transform. We'll go with our pocket. We'll right-click and add a polar pattern. As before, I'll select a reference and I'll choose my datum line. Let's add 7 occurrences. And we'll say OK. And then we can say add a linear pattern. And let's make this length, say, 400. And we'll add some more occurrences. That looks good. How about 6 occurrences? Okay. Add a linear pattern. And you'll notice the graphics are slowing down because patterns are very heavy. So if it slows down on you, just let it do its thing. It'll probably work. Let's go with vertical sketch axis. There we go. Looking good. Okay. And then we'll go with a polar pattern. You can tell we made one hole. And as it's thinking about things, we can make thousands of holes in various patterns like this, all off of one single hole. This isn't going to be a very pretty pattern. Because, you know, it's overlapping and everything, but I think this goes to show the kinds of varieties of things that you can do with just one hole, if done right in FreeCAD. So depending on your hardware, that could take a long time, but there's an example of kind of a messy in the middle pattern that we made. I'm going to say OK to accept that. And as it's thinking about making that into actuality, patterns are heavy, but you can do a lot of patterning in FreeCAD. And there it brought it into actuality. So again, depending on your computer hardware, that could have gotten kind of computationally heavy. I'll go ahead and save that as a pattern example, despite how sloppy that is in the center. All right. This is kind of a heavy part, so let's get rid of that. Let's bring up, say, our house that we made, the very first part. All right, so there's our house. And let's examine for a minute our tree. You can see that we have a body, and everything under this body are the things that make up this house. And several things come to mind. First off, I can hide my chimney feature and show my house body feature. So if I'm ever confused about my tree, I can use the space bar and show things in step-by-step how they made, right? I can say first I made my house, then I go to the next thing and hit the space bar, and then there's my chimney that I made, right? So it's one way to roll it back kind of easily and understand what's what in the history tree if you have any questions. But secondly, here we have this body that encompasses everything. And you may notice this somewhat suspicious button over here that says create a new body and make it active. And so if I click that, then I have body 001, whereas my house is my other body. And so if I go to sketch, well, let me back up a little bit. Right. Okay, so I have this. If I double click on my house body, you can see how that text goes bold. And then I can double click on my body 001 text, and that text becomes bold. So whichever text is bold between these bodies is the active body. If I go to sketch something and extrude something, it will merge with whatever body has the bold text. So in this way, I can have multiple bodies in a single part. Now for me, that's multi-body modeling. That's what you would use it for. And let me give you an example of multi-body modeling. Right now, my body 001 has the bold text. And so I'm going to create that body, right? I can go to this plane and say OK. Now I'm not actually working with my house at all, so I can go to my Model tab, and I can stand on my body and hit spacebar, and it will hide that whole body. And now the only thing that's visible is my body 001, which I'm currently working on. I'll head back over to the Tasks tab under my combo view. And let's say that I make this gigantic hexagon. And I'll select this line, make it horizontal. I'll select these 2 points and Shift V to add in a vertical dimension, right? If that's confusing, I just come over here and say vertical and reselect my 2 points, but Shift V is like a little shortcut on clicking that button. And I say 43, how about? I close that, we'll go into part design and say pad. And maybe I will pad something. Let's go symmetric to plane, and let's say 50 millimeters. All right, so now if I stand on house and hit the space bar, right, I have these 2 bodies that are intersecting, but they're not merged, right? You can see where I have this little black line where edges meet, and there's no black line where these 2 edges meet. They're just 2 bodies that happen to overlap and occupy the same space. Well, there's something called a Boolean that you can use that causes 2 separate bodies to interact with one another. So this is the Boolean button right here, where we create a Boolean operation with 2 or more bodies. So my active body right now is this one because it has the bold text. You can tell if I collapse these, body 001 has the bold text. I can make body bold if I want, just by double clicking on it. And now my body is active. So I click on Boolean, and whatever I clicked is the active body. And I can add a body by clicking the Add Body button and then clicking on the body that I'm adding. And if I fuse these, then I've made these 2 bodies into 1 body. And I can do something like add a fillet in that little edge where they fused. Right now, if I delete my Boolean, go into my tree and hit the delete key, I can't even select the edge that I just created a fillet on because there's no edge there. It's just a place where 2 separate bodies intersect. So by creating the fuse that I just did, by saying Boolean, add body there, and I have my fuse right here, then I've turned 2 bodies into 1 body, and now I can not only select the edge right there, but add a fillet, right? So now this is 1 single part. Okay, let's go with, let's edit the Boolean. My next option is I can cut, right? I can take that hexagon body and cut it away from my house. Remove the whole body. Now the next one is my personal favorite. Let's edit the Boolean again. We can add a common. And a common is saying, hey, you know that spot where those 2 bodies intersect with each other? I only want material to be where they intersect, right? That's a pretty fun one. So that's how we can do some multi-body modeling. We can take two bodies and merge them together, and the common is actually quite useful. All right, so we have our Boolean. Let's delete that. Great, so those are two. That's how you do the Boolean, basically, right? Now let's go over cloning. So I'm going to take my body. You know what, maybe I'll just do a quick save so that if you wish to download this from GrabCAD, you can. We're going to do a save as. Call this Boolean example. So I just saved. I'm going to do another save as. So let's cover ShapeBinder now. ShapeBinder is a really fun tool, and as we've covered, right, this is a body and this is a completely separate body. And ShapeBinder is a tool to manage multiple bodies in FreeCAD. So I go to body 001. We can see it's a hexagon shape. This body here is our house. And when I double click on a body, I'll go back to my model here. The text becomes bold, and that means that's an active body, whereas the not highlighted text means that this body is not active. And what does it mean if a body is active? It means that whatever extrusions or cuts or anything I do applies to the body with the bold text. And no matter how I extrude or cut or anything, it will never affect body 001. If I want to extrude or cut something on body 001, I have to double click that so it has the bold text. And then everything I do will affect it, right? So even though we have multiple bodies in the same part, and even though they take up the same space, you can see they're overlapping here, the active body is the only body that will be edited. So I'm going to make my house active. And let's say that I'm sketching on this face of my house, and I want to reference something on my other inactive body. I can use my import tool, but if I try to import anything, you can see it will not let me import at all. So I cannot import or reference geometry from my inactive body, and that can be a problem in some designs. So what I'll do instead, right, I'll delete my sketch to clean up my tree first. I'm going to click on this button, right, the shape binder. And when I click to create a new shape binder, I am given the option to add geometry. So I'll click on add geometry, and I can select faces and edges. I think I can even select a point, possibly. Maybe not. Click add geometry there. Yep, so I click add geometry, and yep, it even lets me add vertexes. So I can choose faces, edges, and vertexes to reference for geometry. I'm going to say OK. And now I'm going to hide my body. And you can see that my shape binder is actually under my house. And since our import tool will only import things part of the active body, why I have the shape binder here, that is part of my active body now, and I can reference it. So if I click on the same face and I click sketch, you can see that I can import the elements of my shape binder, right? Edges and faces and even that vertex can all be imported to reference off of. And this kind of pinkish brown, or I guess pinkish purplish color, that's just treat it like it's reference geometry, like the blue lines that we've covered. So it's pretty powerful and pretty beneficial to be able to import parts from other bodies to use for our shape binder. It's a great feature. So that's how I use shape binders. And I'm going to delete my shape binder now, and let's cover the next thing. I'll stand on my body and hit the space bar to bring it back into visibility. What if I want to import the entire body and use it for Booleans? Well, we have a sub-object for a shape binder, right? So I'm standing on my body, but my house is my active body, right? So whatever body's active, you stand on the body that you wish to import, and click this green sub-object shape binder, and you can tell it imported the whole thing. I'll turn my body invisible again. And the cool thing about this is you can position it, right? So I can open up this little placement here, open up this little position, and I can say maybe in the Z direction, which I can reference over here. You can see that we're pointing toward the Z over here, the X direct or the Y direction straight up and down, and the X direction over here. So I know what my directions are. And say in the X direction I want to move 10 millimeters, and in the Z direction I want to move 20, right? And I can position this in whatever way I want. I can even rotate this around an axis. So if I have a 1 value in my Z axis and I type 45, then I know it will rotate 45 degrees around my Z axis. I type 45, there it goes. And then I can change my Z to 0 and my X to 1, and it will update that to 45 degrees around the x-axis and so on. So I can position and rotate things the way that I wish. And then I can run a Boolean, right? So my binder, again, is under my active body, my binder subobject. And I can go to my Boolean value, and you can see I can fuse this together into one single body. Or I can do a comment, right? And I can say, well, I only want material where these two bodies overlap. And if there's a body where it isn't overlapping, I want to get rid of that material. Or I can choose a cut. And hey, that makes a pretty cool porch thing. So I think I'm going to keep that, right? So we've made a cut between one of our shapes. We'll close that. And that's how we deal with bodies in FreeCAD, at least with shape binders. One other thing to note, if I delete my Boolean and I delete my binder, and I show my body once more, you can move things around by right-clicking and choosing Transform. And I can move my body and I can rotate it around whatever axes that I want to position this. And I can even make this a different increment. So if I wish to only move 10 millimeters at a time, you can I snap at values of 10 millimeters. And you can also change your increment 4 degrees. Right now we're snapping every 15 degrees. So that's a useful tool. But be careful, because if you try to relocate this body and you try to use a shape binder, and I add geometry to reference this position, it actually adds the geometry to the original position that this body was in. And that's one reason why you want to use a sub-object and relocate the sub-object instead. So one other thing that could be useful, right? I can do something like stand on my body, create a sub-object, and then I can hide my body with the space bar, and maybe I could choose a specific face. And by the way, just so you know, I can, if I delete my sub-object and show my body again, I can highlight, say, one face of my object and still use that in a sub-object, just like I did with face or shape binder. And I can stand on my face, right? I can highlight it and choose something like a pad, and I can create a solid just from one face. Likewise, because I have the flexibility to move things around, I'll hit Control Z here. Because I have the flexibility to move things around, I can say relocate my binder position in the Z direction. Maybe I'll make it 100 millimeters, right? And I can choose something like revolve. I can revolve around a certain axis, just like we do with a sketch. So I can treat those faces as they are a sketch and have the same results, which can be extremely useful. So there's a lot of cool things you can do with multi-body modeling if you need to use more than one body. And some people even use it to simulate an assembly, where you have a model that's made up of multiple parts. I would say That's not the proper way to do an assembly, but it also works really well if you need to do it that way too. All right, let's move on to clone. Okay, so I'm going to stand on my body here, and I'm going to click this little, I have no idea what that is, but to me it has always looked like an orange cyclops. It's actually kind of cool. So I click on this, and it creates body 001, and it doesn't look like anything has happened in the graphics display. But what's really useful is I can transform body 001, and it turns out I made an exact copy or a clone, right? And maybe I can choose the appearance on this and make this blue. So blue is the clone, and this one is just not the clone, the original, the parent and child. And again, you just right click. All right, you right click in the tree and you can choose appearance to do that. Now, between my parent and my child, this is what's really interesting. I select sketch on this. And of course it removes the clone from this view. But as I'm sketching, right, and for the sake of time I won't fully constrain, I'm going to do a pad, and it shows up on the child right through all. So any change I make, it is sent to the child even after I clone it, which is very useful if you need to have the same bodies. And then of course I can, let's grab this body, right click and say transform, right? I can do something like move these kind of together. Maybe I'm going to change this back to 1 millimeter and just overlap them a hair. And I say okay. Then I can choose my two bodies, and then I can even do a Boolean and fuse them together. Isn't that cool? Now, of course, it added that extra one on the end because it it had that extra body in there, so when I fused them together, that was part of the clone that showed up. But you can start doing Booleans with clones, right? You can say, anyway, so that is just a super cool feature that FreeCAD has, that you can do clones with bodies and Boolean them and everything. I'll transform that again. Cool. So that's the clone feature. Now maybe I want to measure stuff between bodies and whatnot. I can choose this little measuring tape, and I can choose this edge. Actually, I can't choose that edge. I should choose a point and another point, and it will show up in my graphics display the distance between 2 points. So I can close that. Now this right here measures the angle between two edges, so I can choose one edge and another edge. And so I can choose linear distances and angles. And then if I update my part, right, if I go into my house body and I edit the pad and I make it 55, well, this still says 50, even though it's now 55. And yeah, then I can use my spacebar to show my pocket there. Well, this, if I click update, will update that to 55. And likewise, right, I can measure from there to there and so on. And so it's really handy to be able to have a visual on some measurements that might be important to you. Likewise, I can clear all dimensions from the screen if I wish. And then I can toggle currently visible dimensions on and off. So this gets rid of the dimensions entirely. If I go to add another, let's say, linear dimension from point to point. Oh, and I forgot to mention, yes, you do get, if you do diagonals, vertical and horizontal components as well as the overall diagonal. Then we can close this, and then I can toggle currently visible dimensions on and off. So this is what it's talking about when it says toggle direct dimensions, right? Just the red one is a direct dimension. And then finally, toggle the orthogonals, right, which go completely up and down. So you have kind of options to say what to toggle on and off. So that's how all those measuring tape dimensions work, and we've gone over all of our shape binders, and I think you have an idea of these datums now. We've gone over how to make new parts. We've gone over subtractive and additive primitives. I think we've covered basically every button in the part design workbench. I have sat here for 3 hours. My voice is being lost. I bet if you listen to the beginning of this video and the end of this video, you can just listen to how much my voice has been lost. I think I barely have a voice right now. I've been talking so much, as well as I just finished up my full-time job today, so it's been a lot of talking today, and my throat hurts. I'm gonna go enjoy, I don't know, a nice warm beverage with my wife, and I hope you've enjoyed this video. I hope it's been helpful. Please subscribe, and I'll catch you in the next video. It's been epic. Thanks.